In this video, we'll talk about how to do the Bruch-Pagan test, but we're going to take the scenic route for it just to understand what we're doing in conducting the test. So this is, a few lectures or few videos before this. We had ran a regression of log wage using the wage1 data set from the Woolrich package on female education experience and married. Okay, so I'm assuming that you've run this and you've stored that as regression 1, or you can call it whatever, but I've called it regression 1. Now, the first step, like we said, the first step is to estimate the equation and then save the OLS residuals and then square those, right? So we want to do that. We want to extract the residuals. So here I'm extracting the residuals from my regression in this way. So I'm storing that and I'm calling those U hat, okay, for lack of creativity here. So U hat is just going to be our residuals from the regression, okay? Now, notice that here I didn't square the residuals, but I ran the regression. This is a very common mistake. You don't want to do that. You don't want to do this step where you're regressing U hat on all these because you're going to get absolute nonsense. You're going to get estimates that are absolutely zero, right? Which makes sense because the expected value of U given X is equal to 0 by design, right, for OLS. So if we do this, we're not getting anywhere. So what we want to do is we want to regress U hat square on all these variables in our regression and then see the F statistic. So notice that the F statistic that is reported and the p-value associated with that F statistic that is reported in your regular regression is basically testing for the joint significance of all of the variables on the right-hand side in your regression, right? It's testing if all of these are jointly 0. And what is this telling us here? This is telling us that the p-value is less than 10% or less than 0.1, right? And this is basically saying we can reject the null of homoskedasticity at 10%, okay? So basically we will say these are results in favor of heteroskedasticity. So this would basically mean, since we are rejecting the null of homoskedasticity, we can say that there is heteroskedasticity that is present and that we should do robust inference, okay? And so basically this is what the Bruch-Pagan test does. And in the lab, I'll show you how to do that very quickly without this method where you're extracting residuals, squaring them, and then regressing. But basically, the idea here is that when you do this type of long method, you can actually see which are the variables that are, notice the variables here that are significant, marginally significant. These are showing that the variability is increasing with education experience and being married, okay? So this is what you want to keep in mind. And also remember that, whenever you are taking logs wherever you can, that is going to decrease the variability that you see anyway in the model. And those models that use logs are going to suffer less from heteroskedasticity than those without, okay?